In this video, we're going to be talking about sampling distributions, and specifically we're going to be focusing on proportions. A sampling distribution is a probability distribution of a statistic obtained from a large number of samples from a population. This is going to make more sense as we go through our first example. So our first example is about everyone in your Algebra 2 class having a bag of 25 Reese's Pieces. Your class wants to find out the true proportion of orange Reese's Pieces. So you might be thinking, oh, why don't I just count the number of orange pieces in my bag, find the proportion, and that's the proportion. So that would work for just your bag, but you aren't going to know the accurate true proportion without finding out the proportion in many bags of Reese's Pieces and then finding the mean of those proportions. So that's what we're going to be doing. So I have on the right, I have an app that simulates this bag of 25 Reese's Pieces, and it's going to count the number of orange for us. So let's start by just doing one sample, and if I click draw sample, it's going to, as you can see, it's separating the orange pieces from all the other pieces, and it says there's 12 orange candies. So as you can see, 12 is great to know that there's 12 out of 25, but we really want to know the proportion. So instead of doing the math 12 divided by 25 ourselves, we can just change the setting to proportion of orange. So instead, when I draw a sample, now it will tell me the proportion. So as you can see, the graph under summary stats, it has this graph. Instead of before, when I had number, our dot was on 12 because there's 12 orange candies in the bag. If I switch it to proportion, the dot is on 0.48. So that's saying that there are 48% orange pieces in this bag. Okay, so that's just one bag. So that's nice to know, but we really want to find out if we take many samples, what's that going to tell us the true proportion is. So let's go ahead and increase our samples to 5 samples. So we're going to do 5 more samples, and it's going to put 5 more dots on this graph based on the proportion in each. So as you can see, the first sample had a proportion of 0.56, so 56% orange pieces. The second one also had 56%. The third one has 52% orange pieces, then 48% orange pieces, and then 52% orange pieces. So those were the 5 more bags that we just counted the orange pieces in. And now there's 5 more dots on our graph. So you can see that they're not all at 0.48, so it's giving us a better idea of around where is truly the center of the proportions. But we still really can't tell because we only have 6 samples, so we really just want to keep getting as many samples as we can. So I'm going to stop animating it because we don't need to take the time to watch that every time because you get the idea of what it's doing. Let's go ahead and do 10 more samples. So if I do 10 more samples now, quickly, there's 10 more dots on our graph now. And you can see that the graph is growing, and we're still having most of our dots around the same spot, but it's still kind of hard to tell what is the center of all the dots. And the center is going to tell us the true proportion. So let's do 100 samples. So if I do 100 more samples, I got so many more dots. All right, so you can see that it's starting to really look like more like a normal curve, and that's what we want. We want to take so many samples that it gives us a normal curve, and then the center of the curve is going to be our best estimate for the true proportion of orange pieces. Let's go ahead and do 1,000. Now the dots are so close together you can't even see them anymore. We just kind of have bars, but you can see that now we do have this normal curve, and this is going to help us to find the true proportion. So let's go ahead and recap kind of what we know by looking at this graph. So the first question we have is, what does the dot above 0.48 represent? So a dot above 0.48 is telling us that one student's bag of 25 Reese's Pieces has 48% orange pieces. So that one dot above 0.48 is representing one student's bag of Reese's Pieces, and it's telling us that there's 48%, or a proportion of 0.48, orange pieces in that specific bag. Now the next question is, what is the shape of the distribution after drawing 1,000 samples? So as you can see, after drawing so many samples, we have a symmetric and unimodal bell-shaped curve, which means we have a normal distribution. And it's important to note that anytime you're trying to find the true proportion of something and you're taking many, many samples, if you take enough samples, you will always get a normal distribution that is centered around the true proportion. So anytime you're doing an example like this, if you take enough samples, you will get a normal curve, and the center of that curve will tell you your best estimate of the true proportion of orange pieces, or whatever your example is. So in this case, I want to find, what do I think the true proportion of orange Reese's Pieces in a bag is? Well, I have my normal curve, and I need to look. I know that with a normal curve, I can just look at the center to find the mean. And if I look at the center, it looks to be around 0. Well, you can see that it's somewhere between 0.48 and 0.56. I'm going to estimate it's around 0.49. And it's okay if you were a little bit above or a little bit below, as long as you're clearly at the center of this curve. That's a good estimate for the true proportion of orange Reese's Pieces in a bag. So just to recap, what we did was we wanted to know what's the true proportion of orange pieces in a bag. We didn't want to just count in one bag, so we did 1,000 samples, and that gives us a normal curve where the center of the curve tells us our best estimate for the true proportion of orange pieces in a bag. So now we're going to go ahead and just do another example where we are already given a histogram, or a dot plot, sorry. So in this case, we want to estimate the proportion of all juniors and seniors that have part-time jobs. Each person in your class took a random sample to create the following dot plot. So as you can see, this one, we obviously don't have 1,000 samples. But what happened was everyone in your class went and took a sample of however many people they were able to talk to, and then they found the proportion of those people that have part-time jobs, and then that created one data point. So let's make sure we understand what each dot represents. So for example, what does the dot above 0.70 represent? Well, that represents that one sample proportion. And that means that, let's say the person with the dot above 0.70, let me point one out. Let's say this person asked 10 juniors and seniors, 7 of them had part-time jobs, 7 out of 10 gave them a proportion of 0.70. So that's an example of what that might have looked like. So it's one sample proportion where 70% of the juniors and seniors had part-time jobs. So each dot is representing one sample proportion of a group of juniors and seniors with part-time jobs. What is the shape of the distribution? Well, if I draw a curve above my dots, you can see that this one is not normal. This one's actually skewed left. And the reason for this is that we probably don't have enough samples. As I said in the previous example, anytime you take enough samples, it will eventually become a normal distribution. But as in this case, you can tell we really haven't taken that many samples, so that's why we don't have a normal distribution in this case. So in this case, our distribution is skewed left. So we can still make an estimate for the true proportion, but it's definitely not going to be as accurate as it would be if we had, let's say, 1,000 samples. So in our last example with the Reese's Pieces, we had a much more accurate estimation because we did get a normal curve because we took so many samples. In this case, we couldn't have taken as many samples, but we can still make an estimate of the true proportion. So to do that, I need to find the center of the data, which I know when it's skewed, whenever I have skewed data, my best measure of center is the median. So I can go ahead and find the median of my dot plot, and to do this, I cross out one dot on each side until I get to the center data point. So we're left with 2 dots in the center. It looks like one is at 0.70 0.66, and one is at 0.7, so I need to find the average of 0.66 and 0.7, which I can get by just doing 0.66 plus 0.7 and divide by 2. And if you do that in a calculator, it will give you 0.68. So we're going to say that we expect the true proportion of juniors and seniors with part-time jobs is 0.68. Once again, this is not the most accurate because it's not a normal distribution. We didn't take enough samples, but this is our best estimate of the true proportion of juniors and seniors with part-time jobs.